Okay, so our episode for today is all about chemical bonding. But before that, let me discuss the activity that you are going to do this week. First activity is all about bonding by transfer of electrons. Objectives of this activity is to illustrate how an ionic bond is formed and to show how ions are formed. You need periodic table. Procedure: select a metallic and a non-metallic element. Write the Lewis symbol of the selected elements. Take note of the electronic value and take note of the electronegativity value of both elements. Subtract the electronegativity value of the metallic elements from the non-metallic elements. With the use of an arrow, show the complete transfer of electrons, then indicate the formation of cation and anion. After that, you will make 5 combinations that will result to a ionic bonding following the steps 1 to 3. You will answer question 1 to 6. Question 1. What kind of elements form cation after ionic bonding? 2. What kind of element forms an ion after ionic bonding? Question 3. What do ions form after ionic bonding? Question 4. Did the atoms attain stability after ionic bonding? Explain your answer. Question 5. How can you tell that ionic bonding will take place between metals and non-metals? And last question, question number 6. Will all combinations of metals and non-metals form ionic bond? Why? Next activity is bonding by sharing of electrons. Objectives: explain how covalent bonding takes place and illustrate the sharing of electrons. In this activity, you need a periodic table. Procedure: show how the sharing of electrons form covalent bond in the following compounds: A. Ammonia, B. Water, C. Hydrogen chloride, D. Nitrogen gas, E. Oxygen gas, F. Methane, G. Hydrogen gas, H. Phosphine, I. Sulfur dioxide, and last, J. Chlorine gas. On table 2, show the data obtained in number 1, the Lewis structure in second column and the type of bond, whether it is a polar covalent or non-polar covalent bond on the third column. And answer the 4 questions. Question 1. How do covalent bonds form between atoms? Question 2. What kind of elements usually? Number 2. What kind of elements usually forms covalent bond? Is it possible for metals and non-metals to form non-polar covalent bond? Why? How about polar covalent bond? Why? Question 3. Is it that diatomic molecules always form non-polar covalent bonds? Last question. Differentiate polar covalent bond from non-polar covalent bond. Last activity is bonding among metals. Objectives of this activity is to make a model of a metallic bond and relate the properties of metals to the kind of bond they are made of. Materials: pencil. Okay, so recall from activity 3, which is all about bonding by transfer of electrons. That's the activity 3, how metals behave to attain stability. Visualize what will happen to a group of metallic atoms. Prepare a model that will represent a metallic bond. You may draw it. Then answer this question. What do you think will make bonding among metals possible? Procedure 4 in the table 3. List all down the metallic properties that you know and try to explain why metal possesses this kind of properties. For example, metallic property is luster. Explanation: metals are lustrous because when light strikes the surface of the metal, they loosely bound electrons near the surface move and reflect the light, giving the metal a shiny appearance. Then on table 4, you are going to list metals that you know, and on the second column you are going to write its corresponding usage. For example, copper, used for electrical wiring, metal sculpture, and a component of jewelry. Okay, so let's start our discussion for today, which is all about chemical bonding. So what is chemical bonding? Chemical bond is a force that holds group of two or more atoms together and makes the atom functions as a unit. Chemical bond holds the atoms or ions together to form a molecules or compounds. The type and number of electrons in the outer electron shells of atoms or ions are instrumental in how atoms react with each other to form stable chemical bonds. To further understand what is a chemical bond, let's first discuss this topic, which is all about Lewis-Dot structure. Lewis-Dot structure is named after Gilbert Newton Lewis, who introduced it in 1916. Lewis was instrumental in developing a bonding theory based on the number of electrons in the outermost, or the valence shell of the atom. Lewis-Dot structure is also known as Lewis-Dot diagrams, electron dot diagrams, or the Lewis-Dot structure and the electron dot structures. Lewis-Dot structure is a diagram that shows the bonding between the atoms of molecule and the lone pairs of electrons that may exist in the molecule. Lewis-Dot structure corresponds with the VSEPR theory. According to the VSEPR theory, there is no direct relationship between the formula of a compound and the shape of its molecule. The shape of these molecules can be predicted from their Lewis structures. However, with a model developed about 30 years ago known as the valence shell electron pair refulsion theory. According to this theory, each atom in a molecule will achieve a geometry that minimizes the refulsion between electrons in a valence shell of that atom. So what is valence electron? Valence electron, it is an electron that is associated with an atom and can participate in the formation of a chemical bond. In a single covalent bond, both atoms in the bond contribute one valence electron in order to form the shared pair. The number of the valence electrons of an element can be determined by the periodic table group, or the vertical column in which the element is categorized. Apart from the groups 3 to 12, the transition metals, the units digit of the group number identifies how many valence electrons are associated with a neutral atom of an element listed under that column. The number of valence electrons that an element has is determined by the number of electrons in the outermost shell or orbit. Okay, so let's look at this diagram of periodic tables. Okay, so these one are the groups of periodic tables. Okay, so we have groups 1 to 18. As mentioned, valence electrons corresponds to the number of groups or the group number, with exception to group number 3 to 12, which is this one. Elements under this line belongs to group 3 to 12. In determining the valence electrons of an element, you are going to look for its group number. For example, group 1 elements like hydrogen, lithium, sodium, potassium, rubidium, cesium, and francium, which belongs to group 1, have a valence electron of 1. Then, elements that have a valence electron of 2 are the elements of beryllium or group 2 and its elements below it, like magnesium, sodium, strontium, barium, and radium. Then the boron group have valence electron of 3. Carbon group have a valence electron of 4. Nitrogen group have a valence electron of 5. Oxygen group have a valence electron of 6, and fluorine group have a valence electron of 7. Group 18 belongs to the group of noble gases and have a valence electron of 8, which is also considered as stable elements. Okay, so periodic table groups. Group 1 are called the alkali metals. They have electron valence of 1. Group 2, they are called as Group 2 is known as the alkaline earth metals, have a valence electrons of 2. Groups 3 to 12 are called as the transition metals. On their fourth shell, they have valence electron of 2 and is considered as complete and cannot hold any more electrons. Group 13 are boron groups, holds 3 valence electron. Group 14, carbon group, 4 valence electron. Group 15, the nitrogens or the nitrogen groups, valence electron of 5. Group 16, chalcogens or the oxygen group, 6 valence electron. Group 17, the halogens or the fluorine groups or the salt forming groups, 7 valence electrons. And group 18, the noble gases, have 8 valence electron. For this part with one asterisk, the general method for counting the valence electrons is generally not useful for transition metals. Instead, the modified d-electron method is used. Okay, so for the group 18, which is the noble gases, all of them have 8 valence electrons, with the exception to the helium, which has only 2 valence electrons. Okay, let's see the Lewis structure of certain elements. For example, is the carbon. Okay, so this is the Lewis structure of the element carbon. As you remember, carbon have an atomic number of 6. Therefore, it has 6 proton, 6 neutron, and 6 electron. That is for the neutral carbon. Now, the valence electrons here of the carbon atom is 4. But the total number of electron of carbon is 6. Okay. So where are the other 2 electrons? So where it is located? It is located in the innermost circle. Okay, so if you will count the electrons of the carbon, 1, 2, 3, 4, 5, 6. Okay, so another way of determining the valence electron of a neutral atom is first determine its atomic number, then you will get the number of its electron. Then fill up the shells. First is fill up the innermost shell. It has a maximum of 2 electrons. Next is the second shell. it can carry up to 8 electrons, third shell of 18 electrons, and fourth shell 32 electrons. Now the electrons on the outermost circle, regardless of the number, will be the valence electron of that atom or element. Okay, so Lewis structure of carbon, this is what it looks like. For hydrogen, this is it, and for phosphorus, that's it. Okay, so the symbol of atoms with dots represent the valence shell electrons. Types of bond. There are three types of bond. First, the ionic bonding, next covalent bonding, and last is the metallic bonding. Ionic bonding, or also known as the electrovalent bond, forms an ionic bond. Ionic bond is the transfer of electrons, and this is what it looks like. Covalent bonding forms molecules. It is done by sharing of electrons. And last, metallic bonding occurs between like atoms of a metal in a free state. Electrovalent bonding, or the ionic bonding. It is the complete transfer of electrons between atoms. It is a type of chemical bond that generates two oppositely charged ions. In ionic bond, the metal loses electrons to become a positively charged cation, whereas the nonmetal accepts those electrons to become negatively charged ion. So, in ionic bond, the metal elements or the metal atoms becomes the positively charged cation or the cation. Metal in this bond loses electrons. Then, the nonmetal accept the lost electron by metals, then become negatively charged anion. So, nonmetal become an ion. Ionic bond requires an electron donor, which is the metal, and the electron acceptor, which is the nonmetal. So metals lose electron and nonmetals gain electrons. So how do we solve ionic bonding, or to determine that a certain compound or molecule is bonded through ionic or electrovalent bond? The bonding between metal and nonmetal is only possible if the difference of their electronegativity value is greater than 1.9. Electronegativity value is the measure of the tendency of an atom to attract a bonding pair of electrons. Okay, so we have an example here of sodium chloride. We have Na or sodium and chlorine, Cl. Electronegativity value of sodium is 0.9 while for chlorine is 3.0. So what are we going to do is 3.0 minus 0.9 equals to 2.1. Therefore, since the value of the difference of their electronegativity is greater than 1.9, therefore electrovalent bonding or the electrovalent bonding or the ionic bonding is possible. Okay, so let's have this example. Chloride salts. In this example, the sodium atom is donating its 1 valence electron to the chlorine atom. This creates a sodium cation and chlorine anion. Notice that the net charge of the resulting compound is 0. After ionic bonding, the sodium becomes isoelectronic with neon, while chlorine becomes isoelectronic with argon. Thus, sodium and chlorine attain stability. Isoelectronic means sodium attain the same electronic configuration with neon. And in the case of chlorine, it acquired the same configuration with that of argon. Thus, both become stable. Example 2 is magnesium chloride. So, we are going to make the Lewis structure of the elements involved. Then we're going to transfer the valence electrons of metal elements to the non-metal elements. So in this example, the magnesium atom is donating both of its valence electrons to chlorine atoms. Each chlorine atom can only accept one electron before it can achieve its noble gas configuration. Therefore, 2 atoms of chlorine are required to accept the 2 electrons donated by the magnesium. As you will notice, the net charge of the compound is 0. Why 0? You have 2 plus here and negative minus charge from the 2 chlorine. So 2 negative, then 2 positive is 0. Okay, so this is the table of electron negativity value for each element. The number in red are the electron negativity value for element. For example, hydrogen we have 2.1, then lithium 1.0, beryllium 1.5, boron 4.0, carbon 2.5, nitrogen 3.0, oxygen 3.5, and fluorine 4.0. As you will notice, the group of noble gases or the group 18 is not included because they are already stable, and that is the basis for electron configuration of the Okay, so what are the factors governing the formation of electrovalent bond or the ionic bond? First, the formation includes the ionization energy. Ionization energy is defined as the amount of energy required to remove the most loosely bound electron from an isolated gaseous atom of an element. The lesser the ionization energy, the greater is the ease of the formation of the cation. Number 2 is the electron affinity. It is defined as the amount of energy released when an electron is added to an isolated gaseous atom of an element. The higher the energy released during this process, the easier the formation will be for an ion. Third, the lattice energy or the lattice energy. It is defined as the amount of energy released when the cations and anions are brought from infinity to their respective equilibrium sites in the crystal lattice to form 1 mole of ionic compound. The higher the lattice energy, the greater is the tendency for the formation of the ionic bond. The higher the charges on the ions and the smaller the distance between them, the greater is the force of attraction between them. Electrovalent bond properties or the properties of the ionic bond. So what are they? Electrovalent compound exist in solid states. The networks of ions have a definite geometric pattern which depends on the size and charge of atoms. Ionic band possess high melting and boiling points due to strong electrostatic force of attraction between the ions. They are also good conductor of electricity in molten or dissolved state. Soluble in polar solvents like water, as solvents interact with the ions of the ionic solid. Okay, now let's proceed to the second band, chemical bond, which is the covalent bonding. So what is covalent bonding? Covalent bonding happens between non-metallic elements with similar electron negativity. It is formed by sharing of electrons. The shared electrons are attracted to the nuclei of both atoms. Ionic bond forms an unstable, non-ionizing particles. They are not conductors in any state. Example includes oxygen gas, carbon dioxide, ethane, water, and silicon carbide. Atoms will covalently bond with other atoms in order to gain more stability, which is gained by forming a full electron shell. By sharing their outermost electron or the valence electrons, atoms can fill up their outer electron shell and gain stability. Nonmetals will readily form covalent bonds with other nonmetals in order to obtain stability, and can form anywhere between 1 to 3 covalent bonds with other nonmetals depending on how many valence electrons they possess. Okay, in covalent bonding, they follow a certain rule which is called the octet rule. So what is this octet rule? It is a principle that bonded atoms share their 8 outer electrons. This gives the atoms a valence shell resembling that of a noble gas. This requires all atoms in a molecule to have 8 valence electrons, either by sharing, losing, or gaining electrons to become stable. So why do elements follow the octet rule? It requires 8 electrons because that is the amount of electrons needed to fill the s and the p orbital, also known as the noble gas configuration. Each atom wants to become stable as the noble gases that have their outer valence shell filled because noble gases have a charge of 0. There are 3 bond formations under the covalent bond: the single bond, the double bond, and the triple bond. On a single bond, when 2 electrons, 1 pair of electrons are shared between 2 atoms, it is depicted by a single line between 2 atoms. Although this form of bond is weaker and has a smaller density than a double bond and triple bond, it is the most stable because it has the lower level of reactivity, meaning less vulnerability in losing electrons to atoms that want to steal electrons. Double bond, on the other hand, is when 2 atoms share 2 pairs of electrons with each other. This is depicted by 2 horizontal lines between 2 atoms in a molecule. It is much stronger than a single bond but less stable. This is due to its greater amount of reactivity compared to a single bond. Last is the triple bond. It is when 3 pairs of electrons are shared between 2 atoms in a molecule. It is depicted by 3 horizontal lines between 2 atoms in a molecule. It is the least stable out of the 3 general types of covalent bonds. It is very vulnerable to the electron thieves. Okay, so let's see how single bond happen. Let's have a example, which is the hydrogen chloride or HCl. H or the hydrogens belong to group 1, therefore it has it have one valence electron. And chlorine belongs to group 17, therefore it will have a 7 valence electron. So what could be the Lewis structure of these two? Then so that is the Lewis structure of the hydrogen chloride. How about for the band diagram? Okay, so this is the band diagram. As you will see, there is one single horizontal line between the two atoms. Next, double band, we have carbon dioxide as an example. Carbon has 4 valence electrons while oxygen have 6 valence electrons. The structure of carbon dioxide would be like this. Okay. Okay, so as you notice, as electrons moves or being shared with the carbon, other electrons move. This is due to the Vesper-theory or the valence pulse or the valence shell electron pair repulsion theory, where atoms would move to the furthermost to each electron. So the band diagram like this one. Next, the triple band. Our example is acetylene. Carbon, 4 valence electron, and hydrogen, 1 valence electron. The Lewis structure of acetylene is like this. Okay. Okay, so on that Lewis structure, the bonding is between the two carbon atoms. The band diagram be like this. Okay, so there is 3 carbon bond. There are 3 horizontal lines between the two carbon atoms. There are 2 types of covalent bond, the polar covalent bond and the non-polar covalent bond. In polar covalent bond, it is created when the shared electrons between atoms are not fully or not equally shared. It occurs when one atom has a higher electronegativity than the atom it is sharing with. The polar covalent bond will result in the molecule having a slightly positive side, the side containing the atom with the lower electronegativity, and the slightly negative side, or the one containing the atom with the higher electronegativity, because the shared electrons will be displaced toward the atom with the higher electronegativity. Example of polar covalent bond is water, sulfide, ozone, and many more. While for non-covalent bond, it is created when 2 atoms share their electrons equally. It occurs when 2 atoms have similar or the same electron affinity. It occurs in gas molecules, also known as the diatomic elements. Example of this is hydrogen gas, nitrogen gas, and oxygen gas. So what are the factors governing the formation of the covalent bond? Since covalent bond is formed by mutual sharing of electrons, therefore, the factor which favors the formation of covalent bonds are as follows. First, ionization energy. Ionization energy of both atoms ionization energy of both the atoms participating in bonding should be high. Number 2, electron affinity. A covalent bond is generally favored between two atoms if both atoms have the high electron affinity. Third factor is the atomic size. The atomic size of the atoms forming covalent bond should be smaller. Smaller the atomic radii of atoms, the stronger the covalent bond will be. For example, hydrogen-hydrogen bond is more stronger than chlorine-chlorine bond, which is more stronger than the bromine-bromine bond. Fourth factor is the electronegativity. The electronegativities of both atoms should be high. The difference of the electronegativities between two atoms should be minimum. So what are the properties of a covalent bond, or the molecules or compounds that is formed through covalent bond? What are the properties of covalent bond, or the compounds or molecules formed under the covalent bond? Covalent compounds, usually in gas or liquid state, have low melting points and low boiling points. These compounds are non-conductors of electrical charge. This is due to the absence of charged ions. Next, solid covalent compounds have soft structures like graphite. This is because of the presence of the cloud of electrons in between each layer of carbon atoms. Also, carbon compounds do not possess polar characteristics as a general property. Therefore, these compounds are insoluble in water. Water molecules are not absolutely neutral and have a slight negative charge on the oxygen atom and slight positive charges on the hydrogen atoms. And since covalent compounds are made up of neutral molecules or molecules with slight charges, hence are not attracted to water molecules strongly. Okay, so last type of chemical bonding is the metallic bonding. It is the electrostatic attraction between the positively charged atomic nuclei of the metal atoms and the delocalized electrons in the metal. In solid state, both metallic and ionic compounds possess ordered arrays of atoms or ions and form crystalline materials with lattice structure. The luster, malleability, ductility, and electrical and thermal conductivity are all related to the mobility of the electrons in the solid. The strength of the metallic bond varies depending on the charge and size of the cations. So, melting points of the metallic bond compounds or the metallic compounds may also vary.